Good morning, and today we're going to look at the derivative of ax to the power of n. So we've already looked at the derivative of x to the power of n, and here we have a constant a in front of that. So when a function is in the form f of x equals ax to the power of n, in general, the rule is still the same. If the function is ax to the power of n, then f dash of x, the derivative of that function, is an x to the power of n minus 1. So it is still multiply by the power and take one off the power, but you already have something in front of the x here. So when you multiply by the power, you're multiplying that constant by the power, that coefficient there by that power. Okay, also, if we have a function that is made up of two separate functions, g of x plus h of x, now that could be 3x squared plus 2x, those could be the two functions, okay? Then f dash of x is simply the derivative of the first function plus the derivative of the second function. And we can think of that as being the derivative of the first term plus the derivative of the second term. So really what we're saying here is that we want to differentiate each term separately. The derivative of a constant is just a number with no x's on it. So the derivative of a constant is 0. If f of x is equal to 5, then f dash of x is equal to 0. The number just completely disappears when you are doing the derivative of that. Okay, so here we have some examples. If f of x equals 2x cubed, then f dash of x is going to be, so you're going to bring the 3 to become a multiplier, but this 2 is already there. So you're going to multiply by the power. So you're multiplying the 2 by the power, and you're subtracting 1 from the power. So you're going to have a 6 now as a coefficient. 2 times 3 is 6, and then the power will be 2, 6x squared. Okay, so it's only a little bit more difficult if you've already got a coefficient in front of your x. And obviously it can get a little bit more difficult again if you're dealing with fractions and things, okay? So f of x equals negative 8 x to the power negative 3. So you've already got the negative 8 in front of your x. So we're now about to multiply by that power, which is negative 8 times negative 3, which is positive 24. And we'll subtract 1 from your power, and negative 3, take away another 1, brings you further down to negative 4. We can take it a little step further by bringing the x back down to the bottom again and making it 24 over x to the power of 4. Now, make sure you're aware of the fact that the two answers for f dash of x are both fine. They're both differentiated and absolutely acceptable formats to leave your answer in. But if you have an answer in one format and you look up the answers in the book and you see that the answer's in another format, make sure you're aware that those two are exactly the same. Okay? So just as we had before, we have to fix this up. We have to make sure we're differentiating a function where the x is on the top and it is as a power. So we have to change that root x back to a power, and we have to bring the x up to the top. So square root of x is x to the power 1 over 2. Just remember that's an invisible power of 1 and an invisible 2 outside your root there, your surd. Okay. And then when we bring the x up to the top, remember the 3 stays down the bottom, and it now comes up to the top level and joins. The 2 stays down the bottom and the x comes up to the top and joins the 3. Okay, so the 2 stays down the bottom and the 3 will now be at the top with the new x. So the 3 is still on the top level, the 2 is in the bottom level, and the x is now there on the top level. It kind of looks as though it's hovering in the middle, but really it's in the same level now as the top, and that's x to the power minus 1 half, okay? So now we haven't even differentiated. We've done quite a lot of work there and we haven't even differentiated. So we're now ready to write down f dash of x. So we have to be careful here. We're multiplying by our coefficient by our power. So we're going to do 3 over 2 times negative 1 over 2. So we'll have 3 times 1 on the top and 2 times 2 on the bottom. and a positive times a negative is an overall negative. So that would be overall negative 3 over 4. So you're doing 3 times the 1 and 2 times the 2. That's how you multiply two fractions together. Multiply the numerators and multiply the denominators. A positive times a negative is an overall negative, and you have that overall negative just hovering in front of the fraction there. So now we're going to subtract 1 from the power. So we've got minus 1/2 already, and we're going to subtract 2/2. So our new power will be negative 3/2, negative 3 over 2. Okay, so that's us now differentiated, and we can leave it like that. If we want to fix it up a little bit, we can bring the x back down to the bottom, and we can also turn it back into a surd if we want. Okay, so I've just brought the x back down to the bottom here, and notice that the x is now in the bottom line along with the 4. You can have the 3/4 hover in front of it when the x is effectively in the top, but as soon as you bring something down to the bottom, you would write it on the bottom beside that. Okay, so negative 3 over 4, x to the power 3 over 2. And if you want to then also bring it back to a surd, remember the bottom of the fraction goes outside the surd, so it'll be a square root, and the top of the fraction is the power. Okay, so it'll be negative 3 over 4 times the square root of x cubed. The top of that fraction stays as the power, and the bottom goes outside. It's an invisible 2 on that square root there, because we don't need to write a 2 outside the surd for the square root. Okay, this is what I mean by the note where we are going to differentiate each term individually. Okay, so it seems a bit more common sense, to be honest. So f of x is equal to this expression here, this function here, and f dash of x is just when you then differentiate each of the terms individually. So for the first term, we're going to multiply by the power, subtract 1 from the power. 3 times 3 is 9, and we'll have an x squared. We do the same for the next one. So negative 2 times 2 is negative 4, and we have an x to the power of 1. We don't write the power of 1, we don't write a 1x. So as soon as you realise you're about to write a 1 there, you just stop yourself. Otherwise, you will have to rewrite it. Okay? And then the next one, so what we're seeing here is an x cubed becomes an x squared becomes an x. So this one here, the x is to the power of 1 right now. And what's 1 power less than 1? It is an x to the power of 0. And if you remember back to your indices rules, x to the power of 0 is just 1. So effectively, the answer is going to be 5x to the power of 0. And as x to the power of 0 is 1, you just have 5x. 5x to the power of 0, and the x has now disappeared. So you see here that every power becomes 1 power less, and the x disappears there, okay, because it is effectively 5x to the power of 0. Okay, so here we have a longer function, and when it tends to be longer ones like this, it can sometimes be easier to do. Even though you've got more to do, it doesn't mean to say that it's harder. So let's differentiate each term one at a time. So we have 4 times 2, which is 8, and the power is going to be 3. Negative 4 times 3, which is negative 12, and the power is going to be 2. And then we have a 6x, and the power is going to be 1. Then the next one is just going to be a 6, because the x power is 0. And x to the power of 0 is just 1, so it's just a 6. And then the last point of the note, which was when you differentiate a constant, the answer is 0, and the 2 just disappears. That's your answer there without the 2 in there. So that one became 1 power less. That one there became 1 power less. That became 1 power less. The x disappears, and the constant completely disappears there. Okay? You'll get used to doing this with some practice. Right, so we're now on to exercise 6F. As always, ask your teacher if you need any help, and take care and good luck.